All right, well, good afternoon, everyone. My name is Miranda Purcell. I'm the Viticulture Extension Specialist at Purdue University, and I'm joined today by my co-host, Dr. Wenjing Guan, and this is the Strawberry Chat, which we hold on a monthly basis, and we discuss upcoming topics in the world of strawberry production. And if you have any topics that you're interested for us to cover in the future, feel free to email Wenjing or myself. I will place our email addresses in the chat. Or I just want to mention that this will be recorded, and we will turn the recording into a podcast that we will email out once the podcast has been completed. With that, I'll hand it over to Wenjing to introduce our guests.
Thanks, Miranda. I'm Wenjing. I'm the horticulture specialist at Southwest Purdue Agriculture Center. And today our topic is about substrate production on elevated systems. Our special guests today are Dr. Kubota and Mark Kroger from the Ohio State University and Richard Horns from Tanglewood Berry Farm in Fort Wayne, Indiana. I'd like to ask our guests to introduce themselves.
I'm a professor at the Ohio State University Horticulture Crop Science Department. I'm also the director of Ohio Controlled Environment Agriculture Center. My research focus has been crop production under controlled environment, including semi-controlled environment or the vertical farm, any type of production facility. Soilless production system, hydroponic production system are the main systems I work on. And then strawberry is my recent addition to my program. Nice to be here. Thank you.
Hi, Mark Krogel. I'm a lecturer here at Ohio State, and I basically teach and support greenhouse or controlled environment hands-on sections of courses that are taught here. I support just about anything that's related to controlled environment agriculture in the department. And I've been, as far as strawberries go, been working with cherry for over 10 years in greenhouse. So understand how promising it is and how challenging at the same time.
Richard Barnes. I'm the owner and manager of Tanglewood Berry Farm in Fort Wayne, Indiana. And it's a family farm where we specialize in berries. We have blackberries, raspberries, blueberries, and strawberries. Been working with strawberries for a number of years, with facing the difficulties that we have trying to grow successfully with ground planted strawberries. So that was the impetus to go with raised benchtop growing. So we developed a system which is still modifying, but we have at our farm a significant number of benches, and we grow day neutrals from late May until the freeze gets us in October. So I'm glad to participate in this project.
Thanks, our guests, for participating today's discussion. In our previous discussion, we almost always centered around in-ground production, that is growing the strawberry in the soil. And we know success of in-ground production, it's really dependent on soil quality, including if there are pathogens, soluble disease, fertility of the soil, and also soil types. It's very challenging, I have to say, to grow strawberry in ground if we don't have a good soil to work with. Even if we do have ideal soil, it's likely disease would accumulate if strawberry are continuing growing in the same ground. All those challenges lead to our topic today, that is to grow strawberry in substrate in soilless medium. This system does require a higher initial investment and a higher level of special knowledge. Critical issue is to understand root zone management. Cherry, Mark, can you start with telling us more about different concepts in the root zone management.
Yeah, so in substrate production in greenhouse is pretty much how it's done. If you walk into any commercial greenhouse strawberry grower, they're using a substrate. And just like in the field, soil is critical. The substrate is very critical in a greenhouse type system. You have to have certain characteristics of the substrate just match the needs of the strawberry plants themselves. Probably first and foremost that I think we run into is that you really need a substrate that's going to have good aeration, in the sense that the roots have access to high levels of oxygen throughout their growing life. Strawberry has one of the highest root oxygen demands of a lot of greenhouse crops. And so we definitely have seen that when substrate doesn't allow good aeration or allow good access to oxygen by the roots, that the plant struggles. So I know early on there was really not a substrate, a strawberry substrate. We developed just one of our own using coconut coir and peat moss and perlite to account for different needs of the plant. And then, but recently there's a lot of commercially available coconut coir based strawberry substrates, and they all are fairly similar in appearance and somewhat similar in their physical characteristics and chemical characteristics. And so it's come a long way in the sense that you can now buy off the shelf a substrate that works quite well for strawberry. It is in fact designed for strawberry. If you look at it, it often has a lot of chunks and fiber and ways to allow air to infiltrate and access the roots. The other thing that the substrate has to do is not be too wet, because strawberry doesn't like overly wet root zone. And part of that is that oxygen thing, but the other part is that it can really promote certain diseases that the plant's susceptible to. And then finally, the chemistry of the substrate is important, because unlike other greenhouse crops like grown in substrates like tomato or cucumber, where large volumes of nutrient solution are applied to the plant pretty regularly, in strawberry we're using a much diminished volume per irrigation, and even the overall irrigation volume for a day is much reduced compared to a tomato plant. That's largely because if you look at a mature strawberry plant, the leaf area is probably about the same as maybe 3 tomato leaves. And so you don't have this huge transpiration demand like you do in the big high wire crops. And so we use small volumes per irrigation and much less total volumes. So the substrate is dominating the root zone as far as pH and EC. And so you need to start with substrates that are in that acceptable range for strawberry, which starting out somewhere in mid 5 pH to maybe 6 as a starting point. And an EC, you can't have, if your substrate starts with a high EC, you need to get that down. Initially, strawberry grows best from what I've observed in a range, EC root zone range of 1.2 to 1.4 or 5, depending on the variety, of course. So all these considerations of aeration and structure and water holding capacity and the chemistry of pH and EC are super critical. And but again, there are commercially available ones that, once you understand how it works, are fairly easily managed to accommodate the root zone needs of the plant.
One thing I like to add is, and then it's a typical misunderstanding and failing point for growers who haven't done any substrate-based production is making production, making the root zone too small. So we recommend at least half gallon of substrate per plant. So if you have 100 plants, you have to have 50 gallons of substrate. So the average substrate per plant is half gallon. Smaller than that, plants cannot grow really well. They get stressed. So compared to, again, the vine crop, the substrate volume relative to the transpiration plants drive is much, much bigger. So the substrate is large relative to the irrigation amount. And then I have seen that growers trying to do teeny tiny substrate in a PVC pipe type of do-it-yourself type of system. That doesn't work. And then it's you can't really produce good amount with that kind of limited root zone environment.
Mark, you mentioned the startup pH around middle 5. Can you describe a little bit of how this pH or EC changed throughout this season?
Well, initially, to get a starting pH, we basically just saturate some of the substrate we'll be using and allow it to sit overnight and then measure the pH. That's what we call our starting pH. But as any plant grows and increases in size and increases its growth capacity, they all tend to push the pH higher. Anion uptake, especially nitrate, increases the pH of the root zone. It's just a matter of chemistry and biology of how that works. And so in an actively growing crop, the pH tends to rise. Also, the lower pHs in substrates, I believe, are mostly promoted by sulfur compounds, and those eventually lose their acidification properties. And so the substrate itself tends to lose any acidifying capacity that it has over time. So yeah, I found that when I'm growing strawberries in substrate systems in greenhouse, that as the crop matures, that struggling with a higher pH is something that typically happens. But again, usually it's manageable, and you can manage it with irrigation. You can manage it with occasional substrate flushes. You can manage it with certain plant maintenance. But pH going up is what I typically see in strawberry fruit production, because we're using largely nitrate with just a little bit of ammonia. So that's where things tend to go. EC also, substrates tend to accumulate certain salts, like sodium. Coconut coir does that quite well. And so the EC can climb eventually as that coconut coir accumulates certain cations. But that's manageable with some occasional flushing of the substrate, or just irrigation frequency, increasing the frequency, but not necessarily the volume. So that's what I've observed.
I think the important thing here is really looking at the root zone, EC and pH over time, and then try to maintain in the acceptable range. So if it is pH, don't go beyond 7. Don't go lower than, I would say 5. I think 5.5 to 7 is sort of acceptable. May not be optimum, right? But acceptable. And then once you start paying attention to the root zone, you see that it can go beyond that easily if you don't manage really well. EC also, plants are so stressed stressed under the salty, condition. So you don't want to go EC higher than 1.2 millisiemens per centimeter, right? So in that case, if you start seeing that, then you want to sort of wash off the root zone to basically save the roots. So that practice doesn't exist in the in-ground production because you don't need to check that. But we pay attention everyday base, and then that's growers do that. Large growers, the greenhouse growers have automated lysimeter system that can check the, drain. The root zone is basically root zone conditions can be found by measuring the nutrient solution coming out from the root zone. So we pay attention to the drain nutrient solution and then measure ECPH. It can be automated if you want to automate, like putting sensor, but volume of the drain and then EC and pH of that drain, in addition to how much you are providing, which is we call drip, and volume of that, EC and pH, all 6 parameters we collect every day base. So that's really key of the success in the substrate production. If you don't pay attention, I think you can still grow plants, but your productivity is not that great. And then also, it's a great time because you can buy, I think somebody asked in the chat, you can buy substrate designed for substrate strawberry production off the shelf, right? You can buy nutrient solution mix, part A, part B, designed for strawberry substrate production. Those didn't exist 20 years ago, but now we have those available. So it may be a little bit more expensive because you are not mixing substrate by yourself. You are not mixing fertilizers by yourself. You are buying off the shelf, but it is a great start because it works. So that's I think what I recommend for those who are doing this first time, as a grower. So
that's a great point. So if I'm understanding Cherry's suggestion for the growers is trying to monitor the EC pH from the leaches as frequent as possible. Like Cherry said, they do that every day. I don't know if our growers is capable to do that every day, but just try your best.
It's only 30 minutes. You don't need to do every single one. You just have a representative setup and then just go there every day and then measure EC and pH quick. I don't know, it may not be even 30 minutes, Mark, if it is just one lysimeter representing the tunnel or greenhouse.
10 maybe.
10 minutes, yeah. But it saved a lot and it gives you tons of information what they are doing.
So other crops may visually show you if they're under stress, but for example, considering EC and strawberry, let's say, again, it depends on the variety, it depends on your conditions, but, I still consider an EC of 2 for strawberry to be high. And it's not high at all in something like a tomato or even a lettuce, but it's high in strawberry. And if you don't monitor that and keep that down in a more favorable level, somewhere in that 1.2 to 1.4 range, strawberry doesn't show the stress symptoms of that until maybe 2 or 3 weeks later, and then it's way too late. And then you end up with this very sad looking crop if you weren't managing that EC, because the salt stress is just taking over the plant. So daily monitoring is essential. That's the way it is with all hydroponic or substrate growing greenhouse crops. And it doesn't take that long. But it is something you must do. So
yeah, so you want to see your plants every day, right? If you're growing crop, you want to go visit your crop and then see if any sign of disease or pests or anything. It's a part of that daily tasks, checking EC and pH of the root zone, or meaning the drainage.
Okay, I see. So the point is, those parameters could change very fast, and if we do see the plants stand looking, that's already too late. and it will takes much more work to trying to correct the problem if we already say the symptoms. So it's better to be preventative, to be on top of that. Okay. The next thing I want to discuss is I want to Cherry and Mark give us an overview of the greenhouse strawberry production system in Substrate. Could you describe the system?
So basically, until we get the European style propagation system in, that is tray plants, we work with what's available, and what's available to us pretty much are dormant bare root runners, which we buy in towards the end of the availability, say in late May. And what we do is we pot those up into individual small but tall pots. We use a tree band, and we grow those over the summer. That requires a little bit of maintenance. If you're using an everbearing type, you have to do some flower removal, some old leaf removal, but it's a high density production system. And so we get those over the summer. And at the end of the summer, we've got usually plants that have either one very large crown or multiple crowns, which is a great starting point because it's a bigger plant. And so, and then depending on your system and your target market, again, if you're using everbearings, you plant maybe late August or certainly no later than early September into your production system. So that's your buckets or your troughs or your long troughs. And then from that point, you need to see, again, for everbearings, you need to see a substantial amount of new growth. So we like to see 5 to 6 new leaves, not the leaves that you were on the plant when you planted it, but 5 to 6 new leaves, because that indicates that the plant is a fairly well-established root system and is on its way to becoming vegetatively massive enough to support fruit load. So at that point, that's when we stop removing flowers from everbearing plants. So in June bearing or short day types, unless you condition the plants to bloom before the natural photo period allows them, they're going to grow vegetatively for quite a while. And so there's really not much of the flower removal maintenance, and they're going to establish themselves very well vegetatively. So then you have crops in your system, you're growing them, you're irrigating them. In this region, you are going to need supplemental lighting towards November, December into January and February if you're going to produce throughout the winter. But basically, during that early vegetative growth phase, you're going to do some maintenance. You're going to remove runners. You're going to remove old leaves. Again, everbearings, you'll be removing flowers. Once you allow flowers to set, you probably would benefit. I know you would benefit if you have the opportunity to do flower thinning, that is, remove really tiny flowers, because those result in tiny fruit. So a little bit of flower management is going on. Of course, all those root zone maintenance things we mentioned, and then of course scouting for pests and diseases. Typically, strawberry being a soft fruit, we really want to avoid pesticides because it tends to have a long harvest restriction. So we use a lot of beneficial insects. Beneficial insect use is preventative, not curative. And so you'll be putting in primarily spider mite and thrips control. Whitefly isn't a huge pest of strawberry, but it can be. So you're looking at plant management, IPM. You're going to be adjusting your irrigation so that as the plant grows, it's going to have a different demand on irrigation. And then again, when the plant's flowering, you're going to want to do some flower removal. Again, tiny flowers mean tiny fruit, so it's best to pull them off. There'll be fruit that doesn't get pollinated well. Pollination has to be done somehow. If you have enough plants, you could probably use bumblebees. Enough plants, meaning 3,000 to 5,000 plants. If you don't, you're going to have to pollinate some other way. Our website discusses that. You can use, say, a low power leaf blower to just cause the plants to shake, and that'll pollinate them. You can hand pollinate with a hand vibrator if you don't have too many plants, just like you might a tomato. But pollination is critical. And if you have enough plants for bees, your bee management is critical. Season ends due to temperature gets too warm. A critical component of greenhouse production is that the nighttime temperatures have to be cool, or your fruit quality suffers.
50 to 55 is the optimum nighttime temperature. Beyond 60, it's sort of quality, penalty. So they're getting more tart and smaller fruits in 15 degrees C, which is, I believe, 60 degrees Fahrenheit. Time is usually a lot higher. So that what Mark was talking about is a nighttime temperature. So the optimum 50, 55. And then if it is going beyond 60, 65, then you should either accept the quality of fruits and maybe process the fruit rather than sell as a fresh market fruit, because it's a lot of tart. I mean, sour tart flavor. Daytime temperature, usually we look at the nighttime and look at the daytime, so the average temperature goes around 18 to 22, that range Celsius. So that means 66 to 75 ish.
Okay.
If you are thinking of unheated high tonal type of structure, it's different way of thinking. So one, I think you want to think about if you want to have harvest before the hard winter starts. And then during the winter time, you have to consider overwintering process. So if you are using a tabletop system, there's no, the heat source in the root zone. So you have to get those things down, on the ground, so that it gets soil heat and cover, limay or some sort of, protection cover until temperature comes back. This process is, in the European country, it says double cropping. So the fall cropping, overwintering, and then spring crop. So you missed the high price season, right? November, December, most of November, and then December, January, February, even beyond, even March, depending on when you can come up greenhouse or tonal to production. But yeah, so there are ways to sort of use that facility for the unheated greenhouse. Although in the Midwest, I recommend to add minimum heating, sort of anti-frost heating, so that you're not losing your crop.
We are talking two systems about the greenhouse productions. The goal is continue producing strawberries. You want to keep the temperatures, as Cherry mentions, the optimal temperature. If we do not have this high-tech greenhouse, another way to thinking is with nest management in the winter. Actually, I think this will lead to what Richard could share with us, because he grows strawberry in Substrate, but Richard is not growing in greenhouse. So, Richard, can you tell us more how you grow strawberry in Fort Wayne?
Yes, sure. Well, we developed a bench system, as I mentioned at the introduction, and we kind of evolved into this over, I'd say, the last 8-9 years of experimenting with elevated growing systems for strawberries. So what our system consists of, it's metal tubular frames that are spaced typically for commercial setup 8 feet apart, and then the ends are tied back, to anchor, and then we have wires, high tensile wires that go through the metal frames from end to end. So we create a very low cost bench system that's very, very open to allow airflow and so forth. And then the wires, the high tensile wires, are spaced to where we can put a 1 gallon fabric, heavy fabric bag, and between two sets of wires. So as an example, on a 102-foot bench, we can get 408 plants on that bench. So that would be the hardware. And then we also have mini tunnels, if you will. So each bench can be set up with a poly tunnel system that you can deploy by cranking, from one end, and so to protect with a rain event, heavy frost, hail, any condition like that. So we've created, I guess, the raised bench tunnel, like a high tunnel, but it's all self-contained into one unit. And then for the maintenance, for managing that, we use drip stakes, irrigation stakes. So each one of the 408 bags has a plant and has a drip stake into each bag. So the bags, as I mentioned, are 1 gallon. We put in 3 liters of substrate, and it's a mix, similar to what Mark was describing, and then we inject minute amounts, if you will, of nutrients with almost every watering, and we will water for typically once a day in the morning. If it's very high temperature and windy, we may do a double watering. So that's how the basic system works. And what we started doing is we start with bare root plants. Again, because of the lack of availability of some of the other plants like they're using in Europe and so forth. So we start those in the typical year, 1st of March, here in Fort Wayne, Indiana. And we plant those into cell trays. And we use a 21 cell tray that's a deep cell. And we will grow those plants in a greenhouse until for about typically about 5 weeks. And at 5 weeks, then we transplant those into the 1 gallon bags that I was describing, with the same substrate. And then depending on the weather conditions, those bags are remain on the ground, or I should say in the greenhouse environment or protected environment until typically towards the end of April. And then at that time, they can be put up on the bench and ready to go. So everything working as planned, with weather and so forth. Our harvest will start typically around the end of May. And again, we're growing all day neutrals varieties. Albion, the variety Albion, has worked very well for us. So we will grow that clear up until frost gets us in the fall, into October. So we get a good 5 months of production. And it's challenging to keep, the quality that you need. But we're doing it. And every year we get a little bit better. We learn a little bit more. So that's a brief overview of how our system would work. And we do also We do overwinter in some cases, so we're trying different things. We also could plant the plants if you did not have a greenhouse environment, let's say to start your starts. You could start those you could plant them directly into the bag. You could forego that you lose some weeks in doing that, of course. And then that planting would happen in maybe April. And then your production would start maybe in July. But then in that case, we would overwinter those plants. Okay, so we would get production would start mid-July, late July, and it would continue until frost. Once the plants go dormant on the bench, we set the plants underneath the bench, and we will cover those plants with a winter cover. In very cold climates, I'd recommend even a layer of straw, okay, on that. And then we leave those plants out over the winter. And then come March, we'll start introducing the plants to light, to the sunlight. Then we'll get a crop, an early crop, a nice crop typically in the spring, and then we'll change the plants out again. Okay, so we'll only get one season with that. We have experimented with carrying plants over that second year, and it's difficult especially with like anthracnose. We have some issues with that. We're getting better at managing it, but we have some plants now that are producing really well, and they're 17 months old, I believe, right now. And we're, after this season ends in a couple months, we will, call those out and start from scratch again. So we're always researching and, trying to find better methods that work in our environment, which is very, very difficult for strawberries with the high temperatures, the high humidity. It's a challenge.
Thanks, Richard. Cherry and Mark is sure with this greenhouse production target, like it's trying to get the strawberry in the winter. That is the highest price you could possibly get. That is dependent if you have this greenhouse system. And Richard is describing a different system, although they're all substrate production. That is, if you don't have those high-tech greenhouse with lower input, what could be achieved? Now I want to go a little bit on the economic. We can imagine those are two different infrastructures to start with, so the economics are very different. I want to ask Sherry first and Mark. Could you share with us a little bit of what you think on the economic part, maybe help farmers, some smaller farmers, they may not have those very high investment, but whether those greenhouse system would be something we could consider. Some economic data, I'm sure, can help them to make the decision.
So we do some analysis in our Indoor Berry website, but we know that always the highest operational expense is the labor, because it's labor intensive production for picking and plant management and all kinds of labor, and then winter crop production, so the utility cost probably comes in, lighting and heating cost. Lighting is quite interesting. So it used to be very, very difficult to justify strawberry production under supplemental lighting because of the efficiency, because of the low productivity. I can't really see the, profitable case if I consider the traditional high pressure sodium light over strawberry. But now LEDs are available. Of course, capital expense is very different for LEDs, but if I just look at operational costs, because of the efficiency, you can make it sense. So that's quite interesting. I don't know if I have that information in my website, but so that most of the new greenhouse growers, northern states do have supplemental lighting, LED lighting, and then heating, right? Natural gas usually. So that's those utility cost is the next, and then materials, transplant cost, substrate cost. IPM is another big, a component of the operational cost. And then we have some data numbers so that, if anyone want to think about, you can look up in our website.
Thanks, Jeremy. Richard, can you talk about a little bit of the economics on your systems?
Yeah, sure. We it's I agree with Harry's presentation there, with labor being a big deal. I can see lighting in that. So what we do, we can't control near as much with our system because we're still exposed to the elements of nature. So we try to manage those best we can. As an example, I had mentioned the tunnel that we have, which works very well during rain events, storm events, and so forth, even heavy dew. Also with frost, we can get through a few frost events with our tunnel. So that, we're extending the season a little bit with that. One of the reasons that I think you need a bench system for trying to grow day neutrals, throughout the summer months, is it's the maintenance that's required, because there's a lot of maintenance to, cutting back runners, small leaves, just on and on and on. That's really quite impossible if your crops are on the ground. I mean, that isn't even thinkable because the labor involved in it. So, but on the bench, it's really quite efficient, we find. We go through the year, we renovate our plants frequently. We cut out dead leaves, just look for disease, the IPM. We keep it pretty clean. So that's a big consideration, but it's not that bad in the scheme of things. One of the things that helps us with the labor is that we can, our workers, we run our whole farm with 2 laborers, and we've got a lot of different moving parts, but we've balanced that with the different crops to where they don't conflict or demand a whole lot of time, crossover. So it balances out very, very well in that regard. So when we irrigate, we have automated systems to irrigate, but I've chosen to do it manually because whenever we irrigate and feed the nutrients, that's when our guys walk the system, the benches, and they do a look over, everything. So that's it. As far as farther on with the economics of it, I think that's a big thing. Your startup costs. A lot of this has been mentioned before. The substrate has went up considerably in costs, like a lot of other items this last couple of years. We're working now on recycling some of our substrate, but we're doing some blending and different things like that to extend that out, and that has helped somewhat. As far as yields go for our system, we can, and I will say that there's not a flat number. It's even from bench to bench, it can vary in year to year and the different things we're doing. But we can average, say, 1 to 1.5 pounds per plant per season, and that's pretty predictable. There are exceptions both directions, to where we've had some really high performance in that, but that's a fair average. I think that you could count on with good management practices. We find too that we sell everything locally to the public, and because of that, and because of the quality of the fruit, which is very high, we get a good price. We're getting $7 a quart right now, and we've raised that since last year. But for us, that's, that works out really well. I think is a very fair price considering, and we have zero pushback from the community, from the customers and so forth. That's not seen as excessive or so on. So, so those are the main things. Are, nutrients, not a big part of the expense. It does feed into there. You have all kinds of things, but it's basically, I'd say your new plants, the substrate every year, and the planting labor for doing that. Harvest labor we have a very good return on that because the berries are very easy to pick off our system. And we also open it for U-pick. So that's another advantage I think that we have. We really control that. It's only open at certain times, throughout the season, but we are there. We have in the past, I've ran performas on what we do that detail our input costs and overall expenses as well as returns. And that's something in the study that we're doing now. In the SARE grant, we will provide detailed information on that. That'll be obviously available here in the near future. But I do think I will close this in saying that it is profitable, okay, what we're doing, and it's a nice complement to the other fruits and products that we're growing, and the customer feedback is extremely positive. So
we are running out of time, but I do want to ask Cherry and Mike one last question. I know some of our farmers in Indiana, I know if they already have the greenhouse and they are really interested in growing strawberries in the greenhouse system, but they kind of new to substrate production. I know things could get very overwhelming immediately and manage EC and manage pH, manage pests. So can you give them some advice, like which might be more important? And also I want to ask you, do you have any recommendation on like books, programs you think can benefit those farmers?
If you're starting a substrate-based strawberry production system, raised bench, like what Richard's doing, and you haven't done it before, definitely start small. Do get as much information as you can, say off websites like ours and others. And hey, you have to grow the plants. I don't know, maybe Richard will agree with this, but if you've never grown strawberry, you don't know how it's going to respond until you actually grow it for a couple of seasons. You don't know how an individual variety is going to respond. We have grown Albion. I was glad to hear Richard mention that variety. It's a real workhorse, and grown well and picked ripe, it's one of the best tasting strawberries out there. That's always part of our plan. But there's a lot of varieties of everbearing. There's a lot of varieties of June bearing, and you want to try several, see which works best in your system or meets your restrictions or abilities best, and just work with it, because it's hard to know how to answer or even sometimes ask questions unless someone's actually grown the plant. And so just starting small and working with it, and don't expect much the first year, and take what you learn and really go at it hard the next year, and you'll gain all that competence and knowledge and skill, and then it's an iterative process, as opposed to something like growing lettuce. So that's my advice. Start small, but do it so that you can learn from the actual process.
That's great advice. Thanks, Mark. Jerry, do you have anything?
Yeah, so in terms of resource, so I share my hydroponic course, soilless production course lectures in my website, and I just shared in the chat u.osu.edu/hydroponics. So you can learn from that, so that little bit of knowledge part. Or if you want a hands-on experience, there are a few workshops available in the country. In Ohio, there's a private company doing a workshop periodically for beginners. And then also University of Arizona has a long-term contributor in that space. So a week long, I think, hydroponic tomato production. It's not strawberry, but understanding substrate management. I think it's a good one. We are hoping to do that in Ohio, but haven't done that. With new greenhouse, probably we might start doing that.
Thanks so much for all our guests to participate in our discussion. So much very, very valuable information. We will end our program today. And thank you everyone participating today. We'll see you next month.
Thanks, Wenjing.
Thank you.
Thank you.
Bye.
Bye.
Bye.